Hello, Mr. Ryan, alright? Given this array of integers, we have n distinct integers. Distinct means that they are unique. So we want to find out that what's the minimum number of the shifts to the right. Shifts.
Will it always be possible?
That's very good point. Yes, it might not be possible. Okay.
Yeah, I know.
So to make the array sorted, for example, like the one shift, I take the rightmost integer and put it on left. It becomes 2, 3, 4, 5, 1. So basically, each integer, so this one becomes I plus 1. This one becomes and the position I plus. Every number is shifted, is moved to the one on the right. The one on the right is put in the front. Okay, this is very straightforward. So for example, the next one is just put it one here. And then whole thing shift one position to the right, and then it's sorted. So the answer for this one is 2 because one shift, 2 shift. Okay. And how about if it's 1, 3, 5? Then we need to return 0 because it's already sorted. Okay. Another example: 4, 2, 5.
Not always. Of course we can.
So for this one,
we can do it. We can do 5, 4, 2.
5, 4, 2, and then what's next?
And then 2, 5, 4.
2, 5, 4, and what's next?
4, 2, 5.
4, 2, 5. Okay, so we repeat, right? Okay, so in this case, we return -1. Any thoughts?
So if you look at it, so for the first one, 3, 4, 5 is going up, and then 1, 2 is also up.
Okay, so yeah,
So-
very good
so-
observation. So what's
So you can take that part and then just put it
yes?
forward as the rightmost part is smaller than the first part of the first ascending sorry.
So how do you find this part? What's this? Why is this number so special?
5
Yes.
because after
It's big.
After that, it drops down to 1, and it stops ascending,
Okay.
and then it just goes down to 1, and then it goes to 2. Yes.
Okay, so given this array, right? So how do you get this number 2? How do we know it's number 2 shifts to the right?
Because there are 2 numbers.
Two numbers
on the
smaller
right.
than
Yeah.
two numbers to the right of the biggest number.
Yeah, that's what I was saying.
Okay, good. So maybe I give it another one, right? So 5, 6, 7, 2, 3, and 4. So so what's the answer for this one?
3.
Yeah,
Three.
3.
Yeah. So how do we know? How?
Because there's 3 numbers to the right of the 7 from the shift to the right.
And then you just those 3 numbers and then.
Okay, then how about I put an A here.
So that is
-1.
Yeah.
Okay, so my question is that how do you know this is -1 and then if this is the
Because if there's the biggest number
Yeah,
to the right of the
you only
smallest number.
can just shift it, and then either way, like this is gonna be next to this, or this is gonna 8 is larger than 5.
Okay, so what's this number so special? For example, like if this is
Because this is ascending, and
Yeah.
then it gets another.
ascending, yes, but in this case this should be -1.
Yes, that's what both of us were saying. It's that it was -1.
Oh, Daddy!
Okay, but you still haven't told me why this is -1. Why this is 3?
Because the last number there
Yeah, the
is
last one.
smaller than the first number there.
And why did you change it
Ah.
to 4, not 8?
It was 8, not 4. It was 4 before.
It was 4. Okay,
No,
okay. So
before
you're
is
saying that. Okay, so
No,
what's this
before
number?
that was
So
4.
so okay, we go through
That was
this.
8.
So we go
Yeah,
through, we
and
find
then
this number,
before that
right?
was 4.
Okay, so we go through we find
Okay.
this number.
I know it was 8. You just keep on saying it was 8, but before that it was 4.
That because it was 8.
Yeah, you just keep on saying the same thing.
Yeah, and?
you're just arguing and saying you say, and then you're like you say, and then I say I wasn't 4 before, and then you realize, and then you just keep saying
Okay, so what's this number?
7.
What's this? I know in the array. What's this number?
7.
I know. What
2.
is it? Biggest or the
2.
smallest?
Biggest.
It's the biggest. Yeah.
Yeah.
Okay, so if we find the
Yeah.
biggest, yeah, or we find the smallest, it doesn't matter, right? So if we find the biggest, then we need to check, right? So there's one way, right? If it is biggest, then we need to find this position, right? This is one way, right? Find this position, and then if this is ascending, then we can put this bit here and then check if it's all sorted, right? This is one approach, right? Okay, before we go into this, right? This is very good approach. We can just simulate the process. You're asking me to shift. So every time I take one, put it in the front, I check if it's sorted. I take one, put it in the front, I check if it's sorted. So how many times I need to do this? Maximum. How many times?
The n-1.
N-1, yes. Is it n-1 or n? It doesn't matter, right? So we'll try almost n times, right? We take it, put it in front. We take it, put it in front. We try this n times, then we rotate it, one cycle. We check if any of those is sorted, right? That's very obvious. Let's simulate, right?
But a very bad method.
It's not that bad. It's very straightforward, but the time complexity, it depends on the implementation, right? So for example, if you want to put this item,
Yeah. To be fair,
yeah.
Ryan, you didn't have a method before, so you can't say it's a bad method.
Because it is.
Okay, so-
You didn't have a method.
I did.
Was that a method just saying yeah?
No, I said it already.
Okay, that's fine. Okay, so this method, okay, as I said, we just simulate the process. I'm not going to write this code because it's not very optimum, because every time you put this in the front, we need to use the DQ, double NDQ. If this is the DQ, Q equals that, then we can say Q dot append left. We want to append left what? Q dot pop, right? Q dot pop means that removing the element on the right hand side, and then I immediately put it on the left hand side, and then we try this n times to see if it's sorted. So we need to check if it's sorted. We need to convert the double NDQ to a list, and then checking if it's sorted. So how do we check if it's sorted? There are two ways. So first of all, we sort this array. That's going to take O and log n time, right? Then once we have O and log n time, we just compare this Q. After the rotation, if this array is the same as that, or if we don't sort it, then how do we check if the array is sorted? We have an array. How do we know it's sorted? Okay, given this, how do we know it's a sorted array? 3, 4, 5, 1, 2. Is this sorted? No, right? So how do we know it's not sorted? How do we check? 3, 4, 5.
Just check if it's like going up.
Going up, yes. So we can say, okay, the next number should be strictly bigger than the previous. 4 is bigger than 3, 5 bigger than 4, 1 is not bigger than 5, so we stop. If we run out, if we iterate from left to the right, if we're reaching the end and we still haven't found this violation, then it's sorted. And that's our end time, right? Okay. So another way, quite similar, right? This is like finding the maximum, and we can find the minimum as well, right? So for example, like this one, 5, 6, 7, 2, 3, 4. The minimum is this one. We can find this. Okay, so now we know the index of this. Let's just put this, because this is the minimum, right? Let's just put this at the beginning. Then we check if this is sorted, right? If it's sorted, then we know, we can calculate, right? Okay? If it's not sorted, then we return -1. Does it make sense? It's quite similar to your approach, right? We're done, okay? How do we find this is the minimum? We use the array, right? If it is array, a dot index, right? We talk about the index function, the minimum a. Min a, this is O(n) time. Find the minimum. An index, find the index. Now find the index, right? Find the index. Then we construct this array. A, if this is index is I, right? A, what's the sound? B equals A I to the n, which is this, plus A up to I, which is this bit. So this is the array. then we just need to check if this B array is sorted, right? And there are two ways of checking it. As I said, if this array, if original array is A, right? So we need to compare with the sorted. So if the sorted array equals sorted A, this is going to take O log n time. And then we just have to check if B is equal to the sorted array of A, then if it is, then return if n is the number of array, okay? Return n minus I, but I need to modulus n. Why? Because if it's already sorted, right? If it's already sorted, then if it's already sorted, the smallest should be at the index 0, right? So n minus 0 is n, but we are not rotating n times. Instead, we can rotate 0 times. Okay, so this is the special case, right? Am I right?
Yeah.
Okay, you get that, right? But how about if this is not sorted? If it's not sorted, then return minus 1, right? Return minus 1. Okay, so the time complexity for this one. This is on, right? To on, which is still on. This bit is still on. And then this bit, right? This bit is the sorted array is on log n, but we can, as I said, we don't need to sort it, right? If we're not sorting it, we just check. Every time we check the previous, if it's bigger than the previous. If any keyword, which is the B, right? BI should be, if it's smaller than BI minus 1, if it's smaller than the previous item, for I in range start from 1 to n, if we find a violation, then return minus 1. Otherwise, we return n minus I modulus n. Okay. So if we're replacing this with this, then the time complexity is on. There's another slightly different solution, which is finding the pivot, right? Actually, this is the pivot. Okay? Pivot. P-I-V-O-T. We call it pivot. So what's the pivot? Okay, going up and then drop. Okay. So, we can make design an algorithm just to find these. This has to be increasing, and once it drops, and the next needs to be increasing. And obviously, we need to make some more checks to make sure it's sorted. But today, we talk about these two approaches. One approach is to simulate. Okay, Ariel, what have you learned?
Okay, so the problem is we have an array, and then we try to shift it, and we want to find how many shifts do we have to do to make it sorted, and if it's not possible, then we return minus 1. So we check ascending and then until it drops, and then ascending. For example, 5, 6, 7, 2, 3, 4. It drops at 7, so it starts at 7 and then goes back to 2, and then it's 3 shifts, as there's 3 numbers after 7, and that's 7 is wherever it stops. The other approach is
What are we finding in this one?
a small.
smallest.
Yeah, smallest, and then
We know the index, then we can
and then we can
put this on the left,
yeah.
and then we check this array if it's sorted. And there are two ways to check if it's sorted, right?
Mm-hmm.
Yeah, because if we find the smallest, then this bit put on the left, this should be the smallest. This new constructed array is sorted, then we can get the shift to move this smallest element to the beginning. This is n minus I, and we need to do the modulus. Because if the array is already sorted, this I would be 0 because it's on the first element. For example, like 2, 3, 4, 5, 6, 7. And in this case, the smallest is on the first one, and the index is 0. Then if you do n minus 0, it's n. It's n shifts. But obviously, it's not an n shift, it's 0 shifts, right? Because it's already sorted. Make sense?
Yeah.
Okay, that's it for today. Bye-bye.
Bye.
Bye.